This one are in parallel, this one are in
Parallel.
and this one and this one are in
Series.
series. Does that part make sense? I'm going to convert to a simple circuit. Let's draw a rectangle. So what is the voltage?
6.
6 volt. And as you see over here, so we have to find the equivalent resistance, right?
Yeah.
How can we do that? 1 over R
Is equal to 1 over
1 over
3
3 plus
plus
1 over
1 over 2.
2. The RN student, are you paying attention?
Yeah.
So 6 and you have what?
2 plus
2
3.
plus 3. So 1
five.
over R is equal to
5, 6.
5 over 6.
So
R
R
is equal to 6. R is equal to
is
6
6
over.
over 5.
And can someone tell me what is 6 over 5 is?
1.2.
Yeah, 1.2.
Alright, so what is the equivalent resistance now?
1.2 ohms.
1.2 ohms. And what about this one?
And this is the 5?
5 ohms. And did you say that this one and this one are in
Series.
series? Okay, this one is in series with respect to this one, and this one is in series with respect to
This one.
this one. Okay. Alright, now let me erase this. Is this a simple circuit?
Yes.
No. This is a complex.
Okay. Oh, I've heard about these. These are mixes of series and
This is
parallel.
series. And we have to convert it to
Simple.
Oh,
simple.
no. We're mixing up series and parallel. We have to work hard over.
Oh, okay.
Okay. So plus, minus, this is 6 voltage, right? Right?
Yes.
And what is the equivalent resistance right now?
You have to add up the resistance.
What is it now?
So 1.2 ohms plus 5 ohms.
What is that?
6.2.
Voltage is 6 voltage.
6 volts.
Okay, and current is? How can you find the current?
V over R.
V-I-R. So V over R.
Yeah.
So 6 over 6.2.
Oh, 0.97.
0.97?
Yeah.
Exactly 0.97?
No, not exactly. This is the actual answer. I'm pulling up the actual answer. It's very
So
complicated.
0.97. Okay. So can you say 0.98?
0.97 is fine because that's a closer estimate.
Why? 0.977 is that what it is?
Yeah.
So
yeah.
if this one bigger than 5, we have to
Oh, okay.
round off to the next whole number. Okay. So 0.98 what?
Amps.
Amps. Okay. Alright, now what was our question? Question is effective. What is the effective resistance, by the way?
Is it
6.2 ohms.
Is it 6.2 ohms or is it 5 ohms or is it 1.2 ohms?
I think it's 6.2 ohms.
6.2 ohms. Okay. Now is the big thing. We're gonna find the voltage drops. We're gonna find the voltage drop. In order to find the voltage drops, you're gonna create a table. Does that make sense?
Yes.
Ohms.
So
This is
2 ohms.
low?
This is
5 ohms.
and 3 plus 2 plus 5
Would
is how much?
regularly be
6.2.
Yeah, it's 6.2. It would regularly be 10, but this time we're not using scalars, vectors, anything.
Right.
Using electrical circuits. So according to Ohms.
According to Ohm's law, 3 plus 2 plus 5 is 6.2.
Oh, yeah.
And what is the current over here?
Current over here is
Is this series?
yes.
Is this series?
Yes.
So should the current be same?
Yes.
Good.
Yes. 4.84. Not the exact answer.
4.84. Is that okay?
Yeah.
Alright, now let's do the resistor in a regular way. Is that okay?
Mm-hmm.
What was it?
It was two of them.
R is equal to 1 point. It was 1.2, right?
I think so. Yeah,
Oh, good. It was 1.2
Yeah.
because
it was.
3
Yeah.
plus 2 is 1.2. Voltage. We don't know voltage, but we know current.
0.98.
0.98. 1.16.
Yeah.
Good.
And I didn't just work that out. I just double checked.
Okay, very good. Now,
Double checked.
what is the final step? Final step is going from series to
Parallel.
complex. Simple to
Oh,
series to
complex.
complex. What is the resistance over here?
5 ohms.
Very good. You remember. 5 ohms, right?
Yes.
Okay, now what is the current, by the way?
Same. 0.98
Very good.
amps.
Current is
0.98 amps.
0.98. Why? Do you know that?
Because current is always the same.
No, that's not the reason. Why is the reason?
The two things are in series with each
Because
other.
this one is series, this one is series, right?
Yeah.
Yeah.
Okay, good.
Yeah, I said that.
Now you said
Everything, the current's all the same.
current would not be same over here. Current would be divided over here because in parallel circuit,
Oh, so it's like slicing into two halves. One has one
That's right.
some
In a parallel
property,
circuit-
the other has its different property that can be split into own circuits.
right? In series circuit, current is same across the circuit. In parallel circuit,
Voltage is the
total
same.
voltage is the same, but the total current is equal to sum of
Sum of the currents at each bulb.
very small.
And just like voltage in the series.
Right. Okay. So what is the voltage?
0.98 times 5 amps.
So 4.83, 4.84 once again.
Oh yeah, we did it
4.84?
before.
Remember?
Yeah, 1.16.
Voltage is
1.16.
why is it 1.16?
Well, in the series, in the same place it was 1.16. And in the parallel,
Now, if you know resistance and if you know voltage, do you know the current?
Yeah!
So current is V over R.
amps.
Yeah, it is amps.
Mm.
All right. Now, shall we change it to the conventional way? What was it? I forgot.
3.
R is 3
Yeah, 3 ohms.
ohms. What we know? Do we know current? No.
Now we know voltage. Again, it's 1.16 volts.
1.6
16 volts.
volt. Do we know current now, Isaac? How much is it, babe? Isaac?
Let me calculate. Give me a sec.
Okay.
So, times 1.2
V over R.
divided by
1.16 divided by
0.39.
0.39
39.
amps, right?
Hmm.
Okay, now
That's
it's
approximately 0.39.
now it's time to fill in the table. So what is the voltage at right here?
Voltage
So,
right there.
1.1.
1.16.
1.16. What is the voltage at right there?
1.16.
0.16. What is the voltage at right here?
1.16.
No,
Now?
4.84.
Oh yeah,
4.8.
4.84.
Now 1.16, 1.16 and 4.84 all together, when you add them up, how much is it?
Let me ask.
Trick question.
So,
6.
it's 1.16.
No, it's 6.
It's 6.
6
These
volts.
two are
Oh, the
The same.
same. I was thinking 7.16. Dang it.
1.16. So it's gonna be 6, and does that make sense?
Yes.
The total voltage has to be
6.
6. Is it 6?
Yeah.
Yeah.
Okay, good.
1.16 times plus 4.84. I actually calculated that in my head.
So what is
Oh,
left?
calculator.
Current.
Current. Okay, let's look at right here. What is the current?
0.39 amps.
Okay, what is the current over here?
0.68.
0.58 amps.
What is the current over here?
0.98 amps.
And that's the same for
Trick
all the others.
question. Trick question. What is the total current?
0.98.
0.98. Total current, we calculated earlier, right?
Yeah.
So total current is 0.98.
Of course it is.
And in fact, if you add them, what is it? Is it 0.98?
No.
No, I don't think so. It's 0.97, right?
Yeah, 0.97.
Well, because we compromised that
Yeah.
decimals.
Decimal.
This 0.98,
Yeah.
split it to 2.
Yeah.
So whatever, it is 0.98.
98.
Now, voltage voltage drops, okay? Now let's see the voltage drops. Okay, now,
Voltage.
how much voltage drops over here? These two, guess how much voltage?
1.16.
Voltage goes over here. And how much voltage comes out from here? Trick question.
Let's see, 6 minus 1.16.
Yeah. How much is that?
4.84.
4.84.
How did you know so fast?
So 4.
It's on the table.
4.84. And this, guess how much? 4.84.
Yeah,
And how much this use?
4.84.
How much it releases?
0.
0 for it to fuel in the negative charge and then shoot out the positive charge for it to all work out again.
So how much voltage drops here?
1.16.
And how much voltage drops here?
4.84.
Alright, now exercise type. You ready?
Yes.
Okay, it's a trick problem.
Really?
Yeah.
You mentioned the word trick so many times, can't keep count now.
Exactly.
This is like your 7th time mentioning it.
Alright, now, how many resistors we have in parallel?
2.
2.
Wait, oh, 2.
If we keep adding,
Uh-huh.
in addition to these two, 3 and 2, right?
Okay.
If we keep adding, 1
Until
ohms, 1 ohms, 1 ohms,
it's like
1 ohms,
Sure.
covered with the
1,000 times.
the
Yeah.
infinite to say n time because you can't say
Well, okay, let's say 1,000 times. Okay,
Yeah.
infinite times. Sure, you like infinite. You see, infinite times. Then what would be the effective resistance?
Effective resistance.
Effective resistance. Remind you, with only 2, what is the effective resistance?
6.2.
Okay, 6.2, right?
Okay.
With millions.
Yeah.
Only you need millions, you don't need like infinite. What would be the effective resistance?
6.2.
6.2.
No.
Okay, wait. No, wait. Let's see. It'll be 1 over.
It's a math problem.
So we can write it out, right? So
Yeah, you can write it out.
equals-
Let's write this one first.
Mhm.
1 over R is equal to 1 over
Work together.
yeah,
3
okay.
plus 1 over
1 over 2.
2 plus plus what?
1 over.
Oh, what is the resistance of the other resistors you're adding?
1.
Oh, all of them are 1.
Yeah.
Oh, okay. So
So just write
it will
1.
approach infinity. So
Plus what?
the reciprocal of that would be
Plus 1, right?
yeah.
Plus 1, plus 1. Okay.
So the resistance will approach 0.
Resistance would be
0.
0.
So then it would be 4 point. No, sorry. No, it would be 5.
It would be 5.
Or you could do the thing 1 over r equal 1 over 3 plus 1 over 2 plus 1
Doesn't
over.
matter. No
Yeah.
matter what way you do, even if you use the sophisticated calculus, the resistance would be
0.
But at least
Why?
infinitesimally small because as you add more ones, then the inverse of r becomes bigger, and that means r itself becomes smaller.
That's right. So 5
Ohms.
ohms.